Okay, today we're going to start evaluating trig expressions using special right triangles. Notice these are the problems you're going to be working on. There's 12 of them. Notice all the angles are either 30, 60, or 45. And as I said that, those angles should sound familiar to you because in geometry, and this year we've been practicing working with 30, 60, 90, and 45, 45, 90 triangles. So in all of these, we're going to be using a reference triangle. And you can actually, as long as you make the sides correctly proportional, you can use any 30, 60, 90 triangle you want. And you can use any 45, 45, 90 triangle. Um, but my suggestion, and notice we're gonna draw pictures of a 30, 60, 90 and a 45, 45, 90, and you should know that they do look different, so take the time to do that. This 30, 60, 90 comes from splitting an equilateral triangle in half. So 30, 60, 90s, and just take your time doing that. Looks something like that. And a 45, 45, 90 triangle comes from splitting a square across its diagonal in half. So this leg and this leg are going to be the same length. Okay, so you can look back in your notes and you can use any side lengths that we've talked about with 30, 60, 90s or 45, 45, 90s. But my suggestion, and this is the simplest form, would be to create one where the short leg has a side length of 1. And then we can fill in the remaining sides here. We know the hypotenuse is going to be double the short leg. And we know that the long leg is a multiple of the square root of 3 times the short leg. So we have to take 1 times the square root of 3. And so this is going to be the reference triangle that I use as we go through these. I would suggest the same thing, but you don't have to. You could make up your own 30, 60, 90 as long as the sides are correctly proportional. Okay, we're going to do something similar on a 45, 45, 90. Again, you can use any that we've worked through, but I'm going to use the most basic form of those. We know that the legs are the same because they came from a square, and the ratio of the sides to get the hypotenuse is the square root of 2. So if we take 1 times the square root of 2, okay, so that should be review for you at this point. Now all these others, and there's some directions here. You can read those as you want. I'm not going to read them to you. Okay, I'm just going to talk you through a couple of these problems here. First thing, make sure that you draw. We're going to draw all these in the first quadrant. This is trig in the first quadrant. Okay, we know that a 30, a 45, and a 60-degree angle all have their terminal rays in the first quadrant. So as you're drawing these, take your time, because a 30-degree angle is different from a 45-degree angle, which is different from a 60-degree angle. So as you draw those, take your time. Okay, so I just drew the terminal ray. The initial ray is always on the positive x-axis. Okay, so from there, this is our 30-degree angle, and I'm going to get a smaller tip pen to write that in. Here's our 30-degree angle. Here's our 45-degree angle. And here's our 60-degree angle. So the next thing we do, we need to get a reference triangle out of that. So the way we do that is from the end of our terminal ray, we're going to drop an altitude for this triangle straight down to the x-axis. Straight down to the x-axis. That's not straight. You can do a better job than I did. And then we can go straight down to the x-axis. That forms a right angle. And straight down to the x-axis. Okay, so now we have a 30 if that's 30 and that's 90, that has to be 60. We have a 45, 90, that has to be 45, so a 45, 45, 90. And here we have 60, 90, that has to be 30 up there. So the next thing we're going to do is identify the sides on the reference triangle. So let's see, if that's 30, 30, opposite that is the short leg. That's 30, opposite that is the short leg. So I'm going to go opposite here. I'm going to label this side 1. Here's our hypotenuse, and here's our long leg of a 30, 60, 90. All right, so now that we have those labeled, and here's our goal. Our goal is to figure out the sine of 30 degrees. And so we're pulling a lot of little concepts together like we do a lot of times as we push forward in math. And for right now, we're finding the sine of 30 degrees, and we know SOHCAHTOA. You can write that out if you want to. All right, we know that the sine ratio is the opposite side over the hypotenuse. So from this 30-degree angle, I'm going to look at the opposite side, it's 1, and I'm going to look at the hypotenuse, which is 2, and I'm going to write that ratio. The sine of 30 degrees is 1/2. All right, let's see. I think I'm going to stop right there. A quick review. What do? We look at the angle. We draw an accurate angle measurement. There's a difference between a 30, a 45, and a 60-degree angle. From the end of that terminal ray, we drop the altitude to the hypotenuse, and that creates a right triangle for us. And then we use our knowledge of trigonometry ratios, sine ratio, cosine ratio, tangent ratio. I just want to point out that these last 3 questions go back to what we talked about last week. Notice that this one is a cosecant ratio. And if you remember back, that is the reciprocal of a sine function. Go back to, I think it was last Thursday's lesson if you need to. Here's a secant ratio, and here's a cotangent ratio. So take your time, draw those triangles out, and stop by my office hours if you have any questions. Good luck, guys.